In this simulation, we are going to look at the stream, single stream for the component methane. As a specification, we are giving temperature to be as 25 degrees centigrade and pressure to be as 1 atmosphere. And the inlet flow rate, which is taken, the flow rate, that means, the inlet flow rate which is taken is 100 kgs per hour. This is per hour convenience. We are planning to take all these things. Okay. So now, if I, so this is the conditions now. So what are the conditions? Initially, it is temperature, pressure, and 100 kgs per hour. But as it is, we know methane, the state of the methane is gas, right? So its boiling point, its boiling point is minus 161.5 degrees centigrade. That means if I say boiling point, external pressure and system pressure will be equal. So that is at 1 atmospheric pressure, if I want the boiling point is minus 161.5, then I wish to check what is the phase, what is the phase. So these are the simple specifications or simple inputs I am ready with now. There is one single stream. I am saying this, there is one single stream. This is one single stream. Already I have shown the videos how to actually build or create a stream. But in this session, what we are trying to do is that we are trying to take a methane as our component and specify temperature and pressure and certain flow rate as per our convenience. Now let me rub all these things now so that it will be clear for all of you. So I think the details are clear for all of you. I think I've shown you the boiling points also. Let us check one by one. How do I do it? So now if I go to the stream conditions, and then I check them now. I take this stream here. Now you can see, first of all, let me change the object name, that is methane. So you can see it has changed. Property package is Robinson. So this is the stream name. This is the property name. These are the input streams. Okay. These are the input streams. Now see the specification, the flash spec. This flash spec is very important in the first instance. So temperature and pressure. I am specifying temperature to be as 25 degrees centigrade here. You can see this. This is the place. And pressure as 1 atmosphere. See, this is the place. And the flow rate, mass flow rate, this is 100 kgs per hour. So this is how I try to specify the conditions which we thought of. Now let us go to the stream again. Now I want to solve this problem. So if I click here and solve, that at the topmost, you can see here, there is a topmost. So you can actually check there and then you can run the program. Now if I go to the solve, it is solved. But if you see this, what is happening here is, you can check here, the vapor phase mole fraction is 1. That means at 25 degrees centigrade, 1 atmosphere with a flow rate of 100 kgs per hour, the vapor phase mole fraction is 1. That means it is the methane is completely vapor. That is what it is actually telling us. Now let us actually change the pressure, only pressure, or rather, only pressure and vapor fraction. We will retain only these two and try to check what is the temperature. Okay. So I go to the flashback. I go to the pressure and vapor fraction now. Now see, pressure is 1 atmosphere and vapor phase mole fraction is 1. See what is happening here? Now again, okay, let me change the color here. Yeah, now the flow rate is still 100 kg per hour, but I'm not specifying temperature here. I'm retaining this 1 atmosphere and the vapor phase mole fraction is still 1. So this is what the conditions are written. How much is the temperature? Okay. That means at these conditions it will become, what will become is it will become the boiling point. So what is the result answer here? You can see the answer here. It is specified here. The answer is what? Minus 161.539 degrees centigrade. You know, exactly how we are trying to see. Now if I, my question is, if I reduce this temperature less than this, you know, retaining the pressure 1 atmosphere, if I reduce this temperature less than this or more than that, what might happen? So that is my question again. So let me rub all these things now. Yeah, again, I think to this extent, I'm also clear. I think you also got the what you call clarity on what we are trying to understand from this particular. Now I change this pressure and now I go to temperature. Now I come to temperature and vapor pressure. Now see again. Now see, exactly see. Actually, the interpretation was wrong. The interpretation here is see, at 1 atmosphere and at the temperature minus 161.539 degrees centigrade, you can see the vapor phase mole fraction, sir. It is 0. That means it is already in liquid condition. Now, if I increase this temperature, you know, minus 161.53, increase means what? I have to come towards 0. I make it 0. Minus 160. See, it is showing me vapor phase fraction is 1. Now if I make it 2, minus 162, let us see. See, that means I am playing beyond this particular, just beyond this particular temperature. Now how do I see that? Now see, that means minus 161.539 is my boiling point. I think you agree. It is less than minus 160. It is greater than, it is greater than minus 162. See, so if I am retaining this pressure and I'm playing just beside this particular boiling point, I'm able to see a change in the phase. What is my interest is that phase, you know, how the phase is changing. So this is the beauty of the thermodynamics, you know, beauty of thermodynamics. Now again, if I change this temperature and vapor fraction at a temperature of 25 degrees centigrade. Now I'm interested in 25 degrees centigrade. At what pressure the vapor phase fraction is 0. See, it is again showing us the result. Now if I see, now at this particular condition, I am knowing, that means at temperature is constant now, 25 degrees centigrade. I want to see at what pressure I have to operate. Yeah. At what pressure I have to operate so that it will be in the liquid state. But I don't know whether to operate hydrogen in liquid state, is it good? Oh, sorry, methane. Whether it is good or not, that is later part. But what we are trying to see is that the methane compound, if I want to operate at 1 atmosphere, what should be the temperature so that it is in the liquid state? Or at what temperatures it is in gaseous state, it is in the liquid state. If I want to operate the system at 25 degrees centigrade, that means normal ambient temperature, at what temperature, till what temperature it is in gaseous state? Beyond what pressure, sorry, at what pressure, up to what pressure it is gaseous state? Beyond what pressure it is going to the liquid state? Two conditions I am trying to speak. See, one condition is ambient temperature. Why? Because I am comfortable to actually operate at ambient temperature. Another condition is atmospheric pressure. You know, I'm trying to see that. One is ambient temperature of 25 degrees centigrade. If I want to operate, what is the pressure? You know, we have fixed 100 kgs per hour and more, and compound is CH4. What is the pressure, or what is the maximum pressure up to which it is staying in the gas phase, beyond which pressure it is in liquid state? Okay. Now we roughly know, or from the simulation we know, it is 620.247 atmospheres. See at what? 25 degrees centigrade. This is the condition. Now I again come back and I change from temperature and pressure. Now see, 25 degrees centigrade and 620.247. Now I change this 620.247 a little, reduce this to a little, 620. Let us see now what is happening. See, that means up to 620.2, or rather, we can say up to 620.246. Yeah, see, then up to 620.2465. See, it is still 6248 liquid state, no liquid state. So my interest is that, see, everybody, you have to understand the methane gas or methane, the compound methane, case 1, if I am operating at 1 atmosphere, till what temperature it is in gaseous state, at beyond what temperature it is in liquid state. I'm very, very simple. Case 2, if I want to operate at 25 degrees centigrade, what is the pressure in atmosphere till which it is gaseous state, and what is the pressure in which it is becoming the liquid state? My only two conditions are there here. So gaseous state and liquid state. I'm trying to understand that. Okay. Okay, then we'll come back with another study wherein we don't have to look at by changing each specification and then check whether it is a gaseous phase or a liquid state. There is a study called sensitivity study where we can, without changing, with being in the simulation, without changing the given input conditions, we will first know at what conditions this is a liquid state or vapor phase. That. So in the next session, we will speak on that.